All right, in this video we're going to be doing the 8.7 day 3 notes. Our objective today is to add numbers in scientific notation. So far we multiplied and divided. Today we're going to be adding, and then tomorrow we'll be subtracting numbers in scientific notation. So when we're adding numbers in scientific notation, the first thing we're going to do is rewrite the numbers, if necessary, so they have the same power of 10, and then add the factors together. So when we think about having a number like 330 plus 500, it's really important that we add and have our ones place, 10 place, hundreds place lined up. If we tried to add our number like this, but we wrote it like this, right, we would not get the correct answer. Our place values would be all off. And so that's kind of our reason for why we need to have the same power of 10 when we're adding. We want to think about it as having our place values in the same spot when we're adding so that we don't get something incorrect like this. Okay, so there's two examples here. The first one, we already have the same powers of 10. So we have 7.3 times 10 to the second plus 5.12 times 10 to the second. So these have the same powers of 10. They're both 10 to the second. So all you're going to do is add your two numbers together. So you're going to add 7.3 plus 5.12. Your power of 10 is going to stay the same. And you can think of it, if you add 300 plus 500, you get 800. That 100 stays the same. And so that's why 10 to the second, 10 to the second, 10 to the second is staying the same. We end up with a number 12.42 times 10 to the second. And then again, like we had in the previous 2 days, this number is not in scientific notation, so we need to adjust it. We need to move our decimal over one spot. That's making our number smaller by 1. So we need to make our exponent larger by 1. So we end up with 1.242 times 10 to the third. In the second example, we have 4.3 times 10 to the third plus 4.12 times 10 to the fifth. Now in this case, our numbers are not having the same power of 10, so we need to rewrite them so that they have the same power of 10. You can make a choice. You could make them both be 10 to the third, or you could make them both be 10 to the fifth. It does not matter what choice you make, you just have to decide to do one. So in this example, they made them both into 10 to the third. So that means our first number in scientific notation stays the same. Now the second one, we're going to kind of use that skill again. So we have 10 to the fifth is turning into 10 to the third because we need it to be 10 to the third so that they're the same. Now that means that our exponent just got smaller by 2, which means our number is going to get bigger by 2. And that'll turn into 412. Okay, and then we're going to add that 4.3 plus 412. Our power of 10 stays the same, so it's 10 to the third. Okay, this gives us 416.3, which again, this is not in scientific notation, so we need to make our number smaller by 2, and then make our exponent bigger by 2, giving us that final answer of 4.163 times 10 to the fifth. All right, again, we're going to go over 4 problems together. So the first one is the nice setup where we have the power of 10s are the same. So we have 1.2 times 10 to the negative third, and then 9.3 times 10 to the negative third. So they're both 10 to the negative third. So our answer will be 10 to the negative third. We need to just take 1.2 and add 9.3. That gives us 10.5. So we would get 10.5 times 10 to the negative third. Okay, we have one step. This is not fully in scientific notation. We need to move our decimal one spot. So we would have 1.05. Okay, our number just got smaller by 1, so our exponent needs to get bigger by 1, meaning it would turn into negative 2. Example 2, again, is a nice setup. We have 2 times 10 to the fourth plus 5 times 10 to the fourth. So they're both 10 to the fourths. So our answer is going to stay 10 to the fourth. And then we just need to add 2 plus 5, which is 7. So we get 7 times 10 to the fourth. This is already in scientific notation. We don't need to adjust it at all. So that is our answer. Number 3, we have 3.5 times 10 to the negative third plus 9 times 10 to the negative fifth. So again, this is not in scientific, or they're not having the same power of 10, so we need to make them the same. Again, you can make them both 10 to the negative third, or both 10 to the negative fifth. It doesn't matter which one you choose, you just get to make a choice. So I'm going to keep the first one the same. So I'm going to write this as, keep it as 3.5 times 10 to the negative third. And I'm going to change the second one. So I know my exponent needs to be 10 to the negative third. So when I think about these exponents, going from negative 5 to negative 3, I'm making my number bigger by 2. So that means I need to make this 9 smaller by 2 places. So I would take my 9, make it smaller by 2 places. So that would become 0.09. Okay. Now that the powers of 10 are the same, I have 10 to the negative third and 10 to the negative third. So my answer is also going to be 10 to the negative third. We're adding, so we're just going to take 3.5 plus 0.09. Make sure we line up our decimals. That gives us 3.59. So we would have a final answer of 3.59 times 10 to the negative third. Our answer is in scientific notation, so we're good to go. Okay, and then the last one, again, when we look at our powers of 10, they're not the same. We have 4.5 times 10 to the negative fifth, and then 4.5 times 10 to the negative fourth. So again, you need to make a decision. I'm just going to keep the first one the same, so I'm going to leave it as 10 to the negative fifth, which means I need to change my second one. Okay, so going from negative 4 to negative 5, that's going down by 1. It's getting smaller by 1. So I need my number to get bigger by 1. So I had 4.5. It's going to get larger by 1 spot, so that'll turn into 45. Okay, now we're adding, so we're going to take 4.5 plus 45. Again, make sure we line up our decimals. We can think of that as 45.0. This would give us 5, 9, 4, so 49.5. And then our power of 10 stays the same, so 10 to the negative fifth. Okay, this is not in scientific notation. We need our decimal to be 1 to the left, so 4.95. That makes our number smaller by 1 spot, so our exponent needs to get bigger by 1. Bigger than negative 5 is negative 4. So that gives us a final answer of 4.95 times 10 to the negative fourth.